Hi, I'm Jen, and today I'm going to talk to you about our paper, Tracing and Visualizing Human ML AI Collaborative Processes Through Artifacts of Data Work. I'm presenting on behalf of my co-author, Anamaria Crisan, from Tableau Research and Salesforce, on our work stemming from collaboration with a team at Salesforce building an AutoML system. AutoML is democratizing data science by lowering the barrier to entry for data science work. But to get started, what is AutoML? AutoML stands for Automated Machine Learning. And the term is used to describe tools or systems that automate parts of the data science pipeline, such as this one we'll use as a reference. By automating parts of the data science pipeline, we can make it more accessible to people with domain or business knowledge, but lacking the technical knowledge to implement such a pipeline themselves. For example, Chef Charles here. To best explain how AutoML works, we have a short example. Charles wants to be able to predict whether a customer is likely to cancel their reservation. Answering questions like this requires considerable technical skills, making it inaccessible for Charles to do on his own. This AutoML pipeline automates aspects of the process, but also provides recommendations for Charles to take or not. Charles uploads some customer data from his restaurant. The AutoML tool recommends some data cleaning steps, and Charles follows some of them, but ignores others. Charles explores his data and the influencing factors that contribute to a given prediction, and he finds some unexpected things in this, such as age being ranked a top factor for the prediction. Charles isn't happy with the performance of the deployed model on a larger data set, so he goes back and adjusts parameters in a previous phase in the pipeline. Charles wants to understand why his model performed poorly, and we do too, and we'll return to this in a little bit. Though AutoML can help Charles answer some interesting questions with his data, and despite the rapid advancement in AutoML technologies and systems, AutoML has its challenges. For one, there is yet to be a tool or system that fully automates the pipeline in its entirety. So it still requires humans in the loop. And in this regard, we can view this process as human ML AI collaboration. And information transfer between human and machine is hard, especially with different levels of automation. And especially if something goes wrong in the process. In addition, human ML AI collaboration adds uncertainty into the capabilities and outputs of these systems, making it hard to scrutinize. For this project, we collaborated with a team at Salesforce, designing and developing an AutoML tool for customers. We wanted to build a visual tool to trace human and AutoML processes across a data workflow to facilitate understanding of this pipeline and how it changes. Not just for the users of the AutoML system that need to understand how things change and what is affected by that change, but also to provide a structure and scaffolding for collaboration, specifically with the team building this AutoML tool at Salesforce, which had a diverse set of expertise. This included machine learning experts, software engineers, user researchers, and user experience designers. But before we could build a tool, we had some important questions that we needed to figure out. For one, how do we make this process traceable? And what are we even tracing? Research into human-human collaboration and knowledge sharing has highlighted the importance of capturing artifacts for tracing complex collaborative processes. Artifacts are captured aspects of a process that can look vastly different for different processes, and we'll come back to this. In our work, we consider an artifact to be traceable if there's a clear definition of what it is, how and when it was generated, and if there exists a lineage of how it changed. These investigations into how to make this process traceable led to one of the contributions of this work, a definition of traceability for ML and AI, which encompasses provenance, transparency, and context. Provenance involves recording individual artifacts and their origins, what generated the artifact, and other artifacts dependent upon it. Transparency concerns the ability to understand how the model arrived at its conclusions. and context is where the artifact exists within the analysis. So, we know capturing artifacts is important, and we know what we need to make the process traceable. What exactly can we capture from these pipelines that we can use to trace? So these questions led to the primary contribution of this work, an AutoML artifact taxonomy that defines a set of artifacts and their properties. The captured artifacts are used to trace an analysis process using an AutoML tool. The benefit of formalizing these artifacts along the pipeline is that it creates a common language for the members of the team, as well as make comparisons between different AutoML pipelines. So this taxonomy describes what generated the artifact. Does it cross the boundaries between human and AutoML processes? What shape does the artifact take? And what is its intended purpose? So there are a variety of ways to create a taxonomy, and this graphic shows an overview of our approach. We used a method by Nickerson, who developed taxonomies for information systems, who describe a systematic approach to taxonomy development in an iterative process with definitive stopping criteria. The approach we took most often in our development was an empirical to conceptual approach, which meant that we gathered, identified, classified, and grouped artifacts we extracted from systems to form our taxonomy. If you want more details about this process, I encourage you to read our paper. So we developed our taxonomy. We collected artifacts from our collaborators' codebase, APIs, and existing parts of the system. And with this, we designed and developed our third contribution, an interactive sketch to operationalize our taxonomy, which we call AutoML Trace. So the purpose of this sketch is to surface and visualize artifacts from an end-to-end automated data science flow that spans the whole analysis pipeline. This was presented to the team that we were working with so they could see and understand how the artifacts are dependent on one another, as well as the breakdown of human and machine-generated artifacts in the process. AutoML consists of three main views that surface process artifacts: the origin view, in the context of the pipeline, what is human-generated versus machine-generated; the dependency view, what is the cascade of dependencies in the pipeline; and the history view, what changed and how did that influence dependent artifacts. Charles wants to understand exactly what was influenced when something changed in the pipeline and how. Specifically, why did his model perform poorly? Luckily for Charles, we created the history view to start to dig into what artifacts changed and what was influenced in the pipeline when it changes. Artifacts that did not change are represented as triangles. Artifacts that did change are represented as circles. So like Charles, one of our collaborators was particularly interested in understanding when humans took machine suggestions and applied them, and when they ignored these suggestions. So what are the implications of this work? It aids in the design and evaluation of human-centered AutoML systems. It can also facilitate collaboration. So this can be used to make what was done more transparent and facilitate collaboration of members of a team that are responsible for different parts of the process. For visual analysis tools, our taxonomy takes a broader view of what can be captured and surfaced from an ML AI pipeline beyond the model or analysis phase. And this can benefit the design and the scope of visual analysis systems to expand their breadth of what is explained and what is visualized to more than just explaining the math or explaining the model. As well, it can enable regulatory oversight. So traceability supports oversight and governance that will be increasingly required for legal purposes. With that, I say thank you for listening to our talk. Get the full story by reading our paper and check out our taxonomy for yourself on this tiny URL.